Good day everyone. Today we will work with KubeClarity, tool for detection and management of SBOM, software bill of materials, and vulnerabilities of container images and file systems. It scans both runtime, K8s, clusters, and CI/CD pipelines for enhanced software supply chain security. If this topic sounds interesting to you, please check out Cisco's Snack Minute, episode 81, where a good overview of the tool is provided. Here, I found out that the lab with KubeClarity is already available in Cisco Devnet Learning Labs Center, so we will leverage it to get up and running with the tool. I will go through part of the instruction. Please go through all of the instructions on your own time. What is container scanning? Container scanning, also known as container image scanning, is the process of scanning containers and their components to identify potential security threats and vulnerabilities within container and their components. It is a fundamental process for container security. Scanning enables developers and cybersecurity teams to fix security threats in containerized applications before deployment. A container scanner is an automated tool that analyzes these various container components to detect security vulnerabilities. Some open source container scanners include Trivi, Claire, Gripe. Scanners pull the image from the Docker registry and analyze each layer. After the first run, scanners download their vulnerability database. Then, after each run, the scanner updates its database. Each day, the community, contained of security specialists, vendors, and so on, identifies, defines, and adds publicly disclosed cybersecurity vulnerabilities to the catalog. Usually, scanners and other security tools use multiple resources for their database. The tool's internal database, external data sources such as searchmaven.org, NVD, Sonatype, OSS Index, and GitHub advisories. The output from the scans contain a list of vulnerabilities, for example, names of components or libraries, vulnerability ID, severity level, unknown, negligible, low, medium, high, and SBOM format. With this output, we can see or write in a file in which package version vulnerabilities were fixed. This information can help you change and update packages or create an image based on the secure one. Container scanners can use templates to write output in JSON and XML. This flexibility is beneficial when you integrate scanners in CI/CD or use the report for another custom workflow. You may find that information from Trivi looks more informative due to the vulnerability abstract and extra links with descriptions. Additional features include ability to scan private images and self-hosted container registries, filtering vulnerabilities. Filtering can help highlight critical issues or find specific vulnerabilities by ID. For example, recently, many security specialists and DevOps engineers searched CVE 2021 44228 log4j, which is related to a common Java logging library. You can reuse this information in many other projects. The Trivi kubectl plugin allows scanned images to run in a Kubernetes pod or deployment. Note, when you run some scanners on your server or laptop, they can take some time to update their database. If you're new to containers, you may want to review these learning labs, Introduction to Containers and Container Management. Today we will proceed with this KubeClarity lab and start learning. We will just editor and terminal window. Okay, so we went through the introduction. First step is set up Istio. Kubernetes cluster creation may take up to 1 minute. To check the status of the Kubernetes cluster creation, run the following command. Okay, Kate's cluster is ready to go. Istio installation may take up to 1 minute. The process starts after the Kubernetes cluster is created. Run the following command to check its status. Istio is ready to go. Add a namespace label to instruct Istio to inject Envoy sidecar proxies automatically. Labeled. Verify that the namespace has been labeled successfully. Great. Note: make sure that all commands have been executed successfully before proceeding further. Let's double check. Next step is deploy KubeClarity. OK. Now let's add Helm repository with this command. Helm repo add KubeClarity and URL. You can see the following message: KubeClarity has been added to your repositories. Let's execute it in terminal. Great, added. Now let's save KubeClarity default chart values. Refresh the list. You should now see a file called values.yaml under source. Check the configuration in values.yaml and update the required values if needed. You can now deploy KubeClarity with Helm. Helm install values, values.yaml, create namespace KubeClarity, 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 namespace KubeClarity. Let's execute it. Great, we see here the thank you message. Note: Helm configures the monitored namespaces only for Istio integration. The default namespace is where the Envoy WASM filters will be deployed to allow traffic tracing. Verify that KubeClarity is running. With this command, kubectl get pods -n KubeClarity. Okay, we have still here one pod in init state, so we'll wait until we see it in a running state. Like here, all ready and status should be running. Issue the following commands to wait until KubeClarity is running. Completion may take up to 40 seconds. So let's rerun the previous command. Okay, great. Now we have all pods ready and in running status. Okay, condition met. Let's clear the terminal for clarity and run this command. Okay, next command. Issue the following command to forward port 8080 to the KubeClarity UI. Great, reload the internal proxy to allow access to the KubeClarity UI. The resulting URL we see here is similar to the following example. Click on the URL to check KubeClarity UI. The dashboard is similar to the following example. After you add a Yelp app for testing, you will be able to explore this configuration further. Okay, let's proceed. Section 3. Deploy services for testing. When experimenting with new technologies, you often follow tutorials that let you deploy purpose-built simple demo applications. Yelp turns this experience the other way around. You start with an existing application and adapt it to the technologies, services, and platforms that you are learning. The following diagram shows the Yelp architecture. You can read more about it in its GitHub repo. Yelp has containers for database, Postgres, caching service Redis, web server Nginx, and app server Ruby. Many applications use components like databases, web servers, and so on. In this example, we can learn how to use vulnerability scanners and integrate them into the DevOps workflow. Let's deploy an app for testing. Now, let's create an Istio Ingress gateway. Check the pod. The output is similar to the following example. Most of them are in the running state, just one is in pod initializing. Let's wait a bit. We will check the app and set the ingress host and ingress port variables for accessing the gateway. Let's rerun the previous battle or kubectl or kube control. Pick your poison. Command get pods. Great. All of them are in running state. Let's check the app and set the variables. Reload the internal proxy to allow access to gateway URL. Display the associated URL to access the API Clarity UI Book Info Applications product page endpoint. Great, we have it here. It says now, you may receive an error similar to the following: upstream connect error or disconnect reset before headers, reset reason connection failure. However, you can still proceed with the lab. If the Yelp pods are operational, they provide enough information to perform a vulnerability scan on all related images. So let's click on the URL. Yes, we see mentioned error. And next. Last section, KubeClarity dashboard. Open KubeClarity dashboard. You'll find it here. At the bottom of the left side menu, click Runtime Scan and then Start Scan button. The user can choose a related namespace from the drop-down menu or leave it empty to scan the whole K8s cluster. Note, after removing namespaces, click Start Scan to reset the entire cluster as the target for the scan. You can also schedule scans and related labels to your scanning results, compare results, and so on. Application Resources menu tab. Over there you can see information about resource name, for example container, resource type, for example container image, Terraform conf files. Okay, let's check what's happening in the UI. Okay, still scanning, 94%. Packages menu tab. Here we can see information about packages and their vulnerabilities. Vulnerabilities menu tab. Here we have a list of vulnerabilities. And filtering features capabilities, packages by license type, packages by name, version, language, application resources, severity by level, unknown, negligible, low, medium, high, and fixed version. After clicking on the vulnerabilities name, CVE- something something, you can see vulnerabilities details with description and external links. Okay, scan completed. We can see here some of the elements were failed to be scanned. See details. Go through the details. Total vulnerabilities. We can filter vulnerability. Affected elements, applications, application resources, packages, and vulnerabilities. Okay, great. Okay, now here we see in the vulnerabilities tab, for example, scanner used to list all of these CVEs was gripe. List of packages. We here see that Sift was used as an SBOM analyzer. And now we see the dashboard populated. With this, we finished this lab. And a congratulations message. As the next step, you can use KubeClarity for your work. If you have ideas or enhancements to KubeClarity, you can open an issue or feature pull request. So to continue working with the tool, check out its GitHub repo. And to further your Kubernetes journey, you can leverage other Cisco Devnet labs and search here for Kubernetes, for example. You will see here available learning labs on the topic, learning modules, and learning tracks. I hope you enjoyed this walkthrough. Until next one.